State security and counterterrorism agencies worldwide are rapidly integrating artificial intelligence to process massive amounts of data and detect threats at high speed. But this demand for technological velocity collides directly with the strict, unyielding frameworks of international human rights law and international humanitarian law, which govern state conduct in peacetime and armed conflict. When a state uses force or strips an individual of their liberty, international law demands that the action be highly individualized, fully aware of context, and strictly proportionate to the specific threat. The reality of modern AI architectures is that they do not produce factual certainty. This diagram illustrates the architectural mismatch. On the left, an algorithmic pipeline funnels chaotic data points into a machine learning model to generate a probabilistic inference, outputting an 87% match based on historical training patterns. On the right, the legal pipeline demands a clear, deterministic chain of evidence to reach a factual conclusion. Relying on an 87% probability to justify a counterterrorism measure inherently corrupts the legal requirement for individual certainty. Applying probabilistic machine learning models to exceptional security environments systematizes human rights violations at scale. This architectural mismatch effectively dismantles the presumption of innocence. In its place, it installs an automated presumption of risk. We can see this friction first in the domain of intelligence gathering and the right to privacy. Traditional surveillance required significant human resources, which forced agencies to target specific, known suspects with a high degree of individualized suspicion. That limitation has been bypassed by vision language models, or VLMs. A VLM is a multimodal AI system capable of processing both visual and textual information simultaneously to generate sophisticated interpretations. Here is a node-based representation of how a VLM processes a single, generic social media photo of a person waiting at a public transit stop. The model does not just identify the face, it extracts contextual meaning from the image, isolating the geographic location, the time of day, a specific book in the subject's hand, and the brand of clothing they are wearing. The system then cross-references these seemingly innocuous visual cues against vast linguistic datasets to infer protected attributes, labeling the subject with profiles like political dissident, religious minority, or highly stressed. The VLM has now generated a predictive profile. This automated inference can trigger deeper, invasive surveillance without any legal standard of necessity or proof that a crime has been committed. This capability extends into physical spaces, particularly at borders. This image shows a digital interface and camera array used for AI-driven biometric identity verification at a security checkpoint. Advanced systems incorporate behavioral biometrics, attempting to read microexpressions or gait patterns to detect deception. However, these systems rely on measurements of human behavior that are inherently variable, physically unstable, and culturally subjective. The persistent collection and retention of this biometric data creates severe risks of function creep, where systems built for security checkpoints expand into broader, permanent monitoring of society. The awareness of this pervasive, semantic monitoring exerts a profound chilling effect on online civic space, causing self-censorship and directly threatening the safety of human rights defenders and journalists. By automating the inference of private associations and beliefs from public data, multimodal AI functionally neutralizes the legal protections of privacy and associative freedom. The application of AI creates similar structural failures within the criminal justice system. Courts and police departments increasingly deploy algorithmic tools to calculate risk scores for bail, sentencing, and predictive policing. The theory behind these tools asserts that analyzing massive volumes of historical crime data can objectively predict a specific individual's likelihood of recidivism or future terrorist activity. Relying on these scores introduces the psychological danger of automation bias among law enforcement officers and judges. Automation bias is the human tendency to defer to technological outputs. As we see in this diagram, a judge on the left carefully weighs individualized case files. On the right, the judge simply receives a high-risk score from a black box server, treating a probabilistic guess as an objective scientific fact. This deference strips the judicial process of human context and individualized discretion. Historical arrest data feeds into the black box, which outputs a high-risk score, leading to a harsher sentence, which then feeds back into the algorithm as a confirmed risk. This black box nature directly violates the right to a fair trial, protected under Article 14 of the International Covenant on Civil and Political Rights, a core treaty guaranteeing foundational legal rights. Because the algorithm's weighting is often protected by corporate trade secrecy, defense attorneys cannot interrogate how a specific risk score was calculated. This opacity destroys the legal principle of equality of arms, leaving the accused unable to meaningfully challenge the evidence presented against them. When judicial independence is outsourced to a proprietary algorithm, the individualized nature of criminal responsibility is replaced by statistical discrimination. The most extreme application of state power occurs in kinetic military operations and the development of lethal autonomous weapon systems. Militaries utilize AI decision support systems, or AI-DSS, which are computerized tools that use artificial intelligence to aggregate satellite, drone, and signal intelligence in real time. In conflict zones, international humanitarian law strictly requires adherence to two principles: distinction, which mandates separating combatants from civilians, and proportionality, which limits civilian harm. Satisfying the rules of distinction and proportionality requires immense contextual understanding and human judgment. This flowchart outlines a standard military targeting cycle: find, fix, track, target, engage, and assess. An AI decision support system accelerates this cycle by automatically recommending a specific target based on fused intelligence data. Notice how the internal nodes of this AI layer are shaded in an opaque, impenetrable black. This opacity creates a crisis of explainability in deep learning military systems. If the AI functions as an algorithmic black box, the human commander authorizing the strike does not actually know why the specific target was selected. This creates an immediate accountability gap. If an unlawful strike occurs based on an unexplainable AI recommendation, it becomes nearly impossible to assign individual criminal responsibility for war crimes. Without transparent chains of responsibility, the entire foundation of legal compliance in armed conflict collapses. A human operator pressing a button based on an output they cannot understand is not exercising human control. They are merely acting as a liability shield for an algorithm. AI integration into counterterrorism acts as a structural force, shifting the balance of power from the individual to the state. The rapid speed of technological development and the pressures of a global security arms race cannot be used as an excuse for regulatory lag. Governing these systems requires a rights-compliant AI architecture that moves beyond vague, technology-neutral laws. This schematic details three structural pillars built over the AI data pipeline: strict legal authorization, explainability mandates, and a final gate for human-in-the-loop controls. The first safeguard requires states and corporate developers to conduct rigorous, continuous human rights due diligence throughout the entire lifecycle of an AI system. The second safeguard strictly dictates that high-risk technology deployed in security contexts must be prohibited if it is incapable of providing transparent, explainable logic to a human operator. The third safeguard mandates meaningful human-in-the-loop controls, preserving contextual judgment in all decisions affecting liberty or life. Implementing these regulations requires massive international coordination. This image of the UN General Assembly Hall represents the scale of collaboration needed to reject the broad exemptions states currently carve out for national security technology. The desire for a technological edge in counterterrorism is a valid state interest, but it can never supersede the democratic rule of law. The ultimate legal baseline is clear. If an algorithm cannot explain its reasoning in a courtroom or a combat zone, it cannot be deployed.